Hi everyone, this is Mr. Maneno from Gainesville Middle School, and I'm back again. I've waited it's been about 6 hours or so that I've had these veggies sitting in either the fresh water or the salt water. And remember, our goal here is to learn something about a process called osmosis. And osmosis is the movement of water in and out of cells. So I want you to see it first, and then we'll talk about it a little bit more in class, and I'll show you some pictures and stuff of what's going on. So what I did is I have some data that I collected that has kind of a day one and a day two. And again, I'm not doing it over 2 days, I'm just doing it 6 hours later, but we'll see if there's a change in the mass. So if you haven't done it yet, again, think about your hypothesis. When I pull them out of the fresh and the salt, do you think they'll gain weight, lose weight, stay the same? And of course, the IV and the DV we talked about before. My IV is going to be the water, whether it's fresh water or salt water. And the DV is going to be my data, which is in this case is going to be the change in mass. And then we'll talk about percent change in class and look at some of the data that way. All right, so let me do my freshwater ones first. So here's my freshwaters. And what I'm going to do is I'm going to drop my little piece of paper towel just to dry them off. I want it to be close as I can to how it was, when I originally did this. And none of these are going to change, really drastically. All right, but this cucumber looks like it's 14.5. So earlier today it was 14, now it's 14.5, so it went up 0.5 grams in the fresh water. Got my freshwater potato here. And this one, that looks like 14.9, and it was 14 earlier today, so that went up 0.9 grams. Carrots and my raisin. Now the other thing to notice about this is these are pretty firm. Like if I try to bend that, it doesn't really bend, right? It feels crisp to me. And that's a clue to what's going on in the cells. These are the same way. They're fairly crisp. If I could break that, if I broke this carrot, it would snap. It's not bendable. It's fairly crisp. So let me weigh my carrot here. This carrot looks like 11.6. So it was 11.4 earlier today, now it's 11.6, so it's gone up 0.2 of a gram. And my raisin is puffed up a little bit. Now, honestly, the only reason I put raisins in here is because sometimes there are students who don't know that raisins are dehydrated grapes. So if you let it sit in water, eventually it'll take on enough water that it starts to resemble a grape again. Never gets quite back to being exactly like a grape, but that's really what it is. It's just dehydrated. And if we can remove all the water from something, think about bacteria and why it grows, right? If I have a dry Jolly Rancher, I can just leave it on the table. Nothing's going to grow on it because there's no moisture. If I put a piece of, ham or cheese or something out here, there's going to be bacteria and mold growing on it pretty rapidly. And the reason for that is because that's what it needs, moisture. So humans have long known that if you dehydrate something, like think about beef jerky, right? If you can dehydrate it and get rid of the moisture, it'll last a long time and you can eat it. This raisin now looks like it's 0.5 grams. So it was 0.2 earlier today, now it's 0.5. So it's gone up 0.3 grams. All right, so all my data is in grams, but you can kind of see the trend here that all of these things in fresh water have gained weight. Now, none of them changed drastically, but they all gained a little bit of weight. And that's a hint of what's going on inside the cells. The other hint is that they have a nice crisp texture. So the first thing we should notice at that is that these have gained weight. Now again, why would they gain weight? The cells aren't reproducing anymore. They're not making new cells. The only thing that really explains that is if water went into the cells and puffed them all up. Now imagine trillions of cells all puffed up tight next to each other. That's what gives these veggies this nice crisp texture, because every cell is puffed up. So the cytoplasm is expanded, it's pushing out on the cell wall, all the cell walls are now pushing together, and you get that nice firm texture we associate with a fresh veggie. So my freshwater ones, each one gained a little bit of weight. Let me do the same thing in saltwater and see what happens there. Again, I'm going to do the same process. I'm just going to dry them out a little bit. I don't want that to impact my mass. And I can already feel that cucumber feels pretty squishy, right? I can bend it more with my fingers. So let's see what its mass looks like. All right, that is looking at 16.8. All right, so we started this morning at 18.2, now we're at 16.8. So that's a difference. It's lost 1.4 grams. So I'm going to put a minus in my chart, 1.4 grams it's lost. And again, I can bend it. I know you can't get a sense for this, but it's very easy to tell the difference between these two. Freshwater one feels like it's not very bendable. This one's more pliable now, more bendable. Let's take a look at the carrot and see what it's doing. Now the carrot you can definitely see. All right, I mean, even at a glance, that carrot is extremely bendable. Whereas my freshwater carrot, I really can't bend at all. I could probably snap it and break it maybe if I was strong enough, but that'll give you a sense for the cells, how pliable and bendable that is now. All right, so this guy's a little bit under 10. Yeah, now this morning this weighed 9.6, this carrot, and right now it's coming in at 8.2. So that's a difference of, that's interesting. I got the same answer for the cucumber and the carrot. It went down in weight, 1.4 grams. Let's try the potato. Dry it off, and again, same idea here. It's bendable now. I can squeeze it. It's much more squishy and bendable than it was before. And that's a hint of what's going on with the cells. Even though I can't see the cells, because the whole thing's made of cells, that gives me a hint as to what's going on. So let's see. This morning that weighed 14.6. And now that is coming in at 12.6. So it lost 2 grams of its weight. And lastly, the raisin. So far everything in saltwater's lost weight. And it showed a more dramatic loss than the one in freshwater. The freshwater ones gained a little bit of weight, but not drastically. But the saltwater ones have all lost more than a gram. Now my raisin, interestingly enough, all these look different, but my freshwater raisin and my saltwater raisin look quite similar. That still looks like it's turning back into a grape. It has not lost any weight based on just what I see with my eyes. And let me just confirm that by weighing it. Yeah, this now weighs 0.6 grams. This morning it weighed 0.3. So the raisin, even in the salt water, doubled its mass. And again, just at a glance, I could see that. This morning it looked much more dehydrated. Now, if I squeeze it, water would come out, where this morning it wouldn't have done that. So we'll talk in class as to why that is. You know, why do they... Let me show you the data here. So hopefully you can see at a glance, and all these are in grams, that my freshwater ones did gain weight, but not much, right? None of them gained more than a gram of mass. And that's because they were all relatively fresh. I just cut the cucumber this morning. I just took the carrot out of my refrigerator. Just cut the potato this morning. So all of these things had fairly healthy cells. They were all fairly fresh veggies. There was a lot of water still in the vacuole. So even if more water went into the cells, we didn't see a drastic change. Now, saltwater, because they were fairly fresh, even though I've only had them in there about 6 hours, you can see that they lost quite a bit. Their change, all of them, both the cucumber and carrot lost almost 1.5 grams, and the potato lost, I don't know why we're at 0.2 in there. It's 2 grams, not 0.2. Oh, that's a minus 0.2, sorry. I can't read my own writing upside down. But yeah, that lost 2 grams. So all 3 of these veggies in saltwater lost weight, except for the raisin. The raisin gained weight in both, and it really gained the same amount in both waters. So we really need to talk about why that is. Why does everything else lose weight but the raisin gains weight? And again, even at a glance, you can probably think that really the only way to explain this is that none of the cells have grown. It's not made new cells. The cells haven't magically died and disintegrated. What's either happened is the cells have puffed up by taking in water, or the cells have collapsed by losing water. If you think about plants that are wilted, or maybe you have some old celery or something in the refrigerator you're going to throw out, and it's really bendable, right? Or when plants wilt, think about what their cells would look like. Cell wall's still there. Cell wall's non-living, it doesn't change. But the cytoplasm, the cell membrane, literally will pull away from the cell wall, leaving us some space. And that space is why that veggie is so limber now, because there's a lot of space inside there where the cell walls are no longer puffed up, right? When they're puffed up and tight, you get a veggie like this carrot that, I don't think I can break it, it's a little small, but it would snap and break, whereas this guy's much more bendable, and it also lost weight. So we can use our observation skills to look at it and say there's definitely a difference, I can feel a difference, I can see a difference, and I can also weigh them and see a difference there. So we'll talk about this data, we'll talk about what it means and why they did that, but as we do this, be thinking about, if I looked at this under a microscope, what difference would I see in the cells under a microscope? And what does this have to do with me? Does it have anything to do with me when I drink water? How's that water get into our cells? So that's kind of what we're going to talk about coming up, but I just want you to see the big picture before we do that.